Today I repaired a Luminious ecovolt 2 kVA, 24-volt inverter that was completely dead when tested on batteries. When an inverter refuses to power on from batteries, the first thing to check is the MOSFET drive section. Because MOSFETs are the heart of the inverter's power conversion, I started by checking the gate pulses on both the high side and low side MOSFETs. The IRF7545, these pulses are very important because they tell the MOSFETs when to switch on and off to produce AC power. What I found were irregular pulses, which means the switching was unstable. Interestingly, when I tested the MOSFETs on the board with a multimeter, they appeared fine. This shows that a MOSFET can pass basic meter tests but still fail under real operating conditions. To be sure, I removed all the MOSFETs and tested them outside the PCB. That's when I found one faulty MOSFET on the low side. The low side MOSFETs are responsible for completing the current path during switching. So if one fails, the inverter cannot start. After replacing the bad MOSFET, I checked the gate drive path and discovered a faulty 2.2 ohm resistor on the gate line. This resistor controls the gate current and protects both the MOSFET and the driver. When it goes bad, the MOSFET will not switch properly, leading to irregular pulses. This gate resistor is connected to the 7295 driver IC. The driver IC's job is to amplify control signals from the inverter's logic circuit and deliver clean, strong pulses to the MOSFET gates. If the gate resistor is faulty, the driver IC cannot do its job correctly. Even after these corrections, the inverter still showed unstable pulses. So I continued tracing the control circuit and found faulty LM12231T1G transistors. These transistors act as signal switches and buffers between the control logic and the driver stage. When they fail, the timing and shape of the pulses become distorted. 3 faulty LM12231T1G transistors were replaced. I also replaced a 6-pin IC, the LMRM4206XMKX. This IC is part of the inverter's power management and regulation section, helping to supply stable voltage to the control and driver circuits. Without stable supply voltage, the inverter logic cannot operate correctly. Finally, I replaced a faulty DIP-type power indicator, which confirms when the inverter is properly powered and running. After all these components were replaced, the gate pulses became clean and stable. The inverter powered on successfully from batteries, and normal operation was fully restored. This repair shows why proper diagnosis is more important than random replacement. Understanding how each component works makes all the difference. Lesson learned: don't trust static tests alone. Follow the signal, understand the circuit, and fix the root cause. That's real inverter repair.
Smiling on the outside, broken deep inside. Everyone is talking, but nobody sees the heavy heart I'm carrying on my knee. I try to hold apart, but I'm slipping away. I try to stand strong, but I'm losing my way. Father, can you take this pain from me?